Okay, here's the quiz. We went over it together in class. I'm going to go ahead and take pictures also and post it on Blackboard. But on number 1, it said here, Mike calculated density of aluminum 3 different times. Now, aluminum's true density is 2.70. And are his measurements accurate, precise? Both, neither. Precise was the correct answer. Okay, because all 3 of them were fairly close to each other. And not only that, but 2 of them were actually the same exact number. Okay, he was definitely not accurate because 2.7 would have been accurate. Now, Mike must have did this experiment again at another time because he got 3 different numbers, or the same, but this one was a different one. And it says calculate his percent error on trial 3. So here's trial 3. Make sure to round it. Hopefully what you should have done here was the true value subtracted divided by the true value times 100. Okay, there goes your answer. The next one, convert the next equation here, or the next conversion, but use dimensional analysis. Meters to inches. So let's go ahead and start off with what I have, 2.4 meters. I have to put meters down here. Why? Because I need to cancel out. Let me go grab that so that way I can do this for you and do the steps. So I need to grab the I'm going to go ahead and use my foldable because I know that my units are all right here pretty much. Again, we're going to add to this starting, I think, next unit. We're going to add a little bit more to this. But I need to go from meters to inches. And by any chance, is there anything over here that's meters to inches? There's inches, but that's centimeters. There's inches, but that's feet. There's meters, but that's miles. Ah, 1 meter equals 39.37 inches. So we should have wrote 1 meter equals 39.37 inches. And I'm looking for this, and that's my unknown. Okay, I can cancel out the meters. I'm left with inches, so I can be done, do my math, and hopefully you got a number something like that. The next part here, we have this little block or cube, and the chemistry student found that the mass of it was 12 grams. And use the dimensions of the block to find the actual volume, which is 5.5 milliliters, and calculate the density. After completing this lab, the student said that the block, if placed in the water, will float. Is this statement true or false? Now, it should be false, and the reason why is because if I got 12 and divided by 5.5 milliliters, I would have got a bigger number, like 2 point something. And water is 1. This is going to be greater than 1. Anything greater than 1 is going to sink, not float. Write the following in scientific notation. You had to move the decimal place over this direction. This is a small number. Small numbers equals negative exponents. Okay? Write the following number in scientific notation. Well, let's turn the page. In this case, this is a large number, so it equals a positive exponent. And there goes our answer. The next one. Take the following number out of scientific notation and put it into standard form. Here it is. Now that's a negative exponent, which equals a small number. Okay? Small number as in a decimal. Now they want to do the same thing here, but I see that this is a positive exponent, which equals a large number, which is something greater than 1. Okay? An irregular shaped stone was lowered into a graduated cylinder holding a volume of water equal to 3.5 milliliters. Now the water height rose, so if the water started off at 3.5 and it went up to 12.7, what we're going to have to do here is we're going to have to subtract. We need to do that so we can find the difference and find out how much milliliters this stone is. They gave us the mass. So density equals mass over volume, or 29.5 over, once you subtract those two numbers, whatever you get here, you need to place over here. Okay, you should get something like that. Please go back, maybe practice and double check. Joshua using a thermometer and finds that the boiling point of ethyl alcohol is 75 degrees Celsius. Now he looks at a reference book and it says that it's actually 80 degrees Celsius. Okay, what is percent error? 80, take away 75 over 80 times 100 equals your percent error. Okay, in chemistry class, or in a chemistry experiment, which of the following statements is not true? We talked about this. You cannot, no, you absolutely can be accurate and precise at the same time. So that is not true. Convert 13.5 grams to the equivalent mass in ounces. Round, it says here. So what do? I'm going to underline what I have. I'm going to circle what I'm looking for. Write down what you start off with. Grams is at top, grams has to be at the bottom. Now I'm going to go back to my chart over here and I'm going to see if there's anything by any chance that says grams and ounces. And I do. I actually see that. I see this right here, 28.35 is equivalent to 1 ounce. And that's grams. So that looks like that's going to work. I'm just going to take a look. This is ounces over here. I'm looking. This is pounds and ounces. This is 1 cup equal 8 ounces. So we're looking for equivalent mass in ounces. Well, I know because it says over here, using this chart right here, that 1 ounce is equivalent to 28.35 grams. So 28.35 grams equals 1 ounce. My grams can cancel out. I'm left over with ounces. Let's do our math and hopefully you got something like this. Okay, the next one. It says here that you calculate the density of silver twice. Based on the mass and volume data, here's what you got for density. Silver actually has a density of 10.50. For the most accurate trowel, which would be this one, calculate the percent error. So here would be 10.5 subtracted by 10.1 divided by 10.5 times 100. Hopefully you got something like that. Alrighty, that should be it for our quiz. I will take pictures and post those as well. Thank you.